Hi guys, so I'm going to start off by explaining Prop 1, which is explain what principles are involved in holding the two alpha helices together, and also explaining what could place leucine that would maintain the hydrophobic core and one that would destabilize it. So for starters, two alpha helices can be held together with disulfide bonds, ionic bonds, hydrophobic interactions, or hydrogen bonding. In this particular case, is the hydrophobic interactions between the leucine molecules and the electrostatic interactions between glutamate and lysine. The principle behind the hydrophobic interactions is to increase the stability of the complex molecules, so all of them just couple together, and together they're more stabilized and they're closely just coupled and come together. The principle behind the electrostatic interactions is that the opposites attract each other. Isoleucine could replace leucine, which is an isotope of that particular molecule. They have the same chain length, they're equally hydrophobic with the same mass, given that they are isotopes, so that would be a good replacement, and it would keep the hydrophobic core since they share the same qualities. Any hydrophilic residue could destabilize the core because they want to be exposed to the aqueous solution that's in the opening. So in hydrophilic molecule that could replace it would be arginine or serine. Arginine, for example, is a polar molecule with 3 nitrogens atoms in the side chain, and it's also polar. These 3 nitrogen molecules are able to make hydrogen bonding with anything that's polar. It's going to attract polarity, and this is going to eventually destabilize your hydrophobic core and make it hydrophilic, and the molecule will no longer be coupled together and the core will start to crumble. And with it having 3 nitrogen atoms, it gives it a pretty wide range that it can, what atoms it can bond with. It has a lot of opportunities to make a polar bond, make a bond with something that is polar. Now on to Prop 2, which was propose a different amino acid pair whose side chains could interact in a similar manner to lysine and glutamate. As long as we have one pair, as long as the pair one is acidic and one is basic, I feel like it could interact in a similar manner. With that being said, I chose the side chains histidine and aspartate to be the side chain that could interact similar as lysine and glutamate. I think histidine and arginine could as well, but I'm not very sure on that one. But yeah, that is basically all I have.